Thank you very much. I'm quite happy to be here as a kind of exotic person in the LIT. But as the LIT is about technological development, there's also a kind of part what are social economic consequences of technological development. And this is what we are about. I'm coming from the Department of Economics, and I'm basically exactly looking at the issue what effect technological development might have on the labor market, on persons employed or unemployed. And this is joint work with Bernhard Schmidpeter from Essex. Basically, what we are interested to understand how routinization can have an effect on the labor market. And in principle, we can think about jobs or tasks becoming routinizable. And what I mean with routinizable is I can clearly define what routinizable is. Can you define a task so precisely and comprehensively that either a computer or a robot can do it, or a person somewhere in China with very cheap wages? And this person basically would get at least what she has to do, and the computer will also get the least what the computer has to do, and then the computer can do it. This is how we define a task, whether the task is routinizable or not. And there has been a long discussion in the economics and social science literature that the loss of routine jobs has been documented for a couple of countries. And basically, the idea was that in the last 10 or 15 years, the number of jobs with more routine work disappeared across the Western world, starting from the United States, but also in Europe. And jobs which are not routinizable are basically expanding. So the number of such jobs has been increasing over time. So to give you an example, so what I want to do is I want to see what happens to workers with such routine jobs. I want to understand whether they will stay unemployed longer, and the question is, could we retrain the workers to do something else that would help them to get better jobs later on? An example about a routine job. And the question is, can a sales job be routinized? And of course, we can have different opinions depending on what quality we want to introduce. But basically, how I'm proceeding here is just in the following. I basically assume that such a sales job has 6 components. I call them tasks. Okay? And these tasks are to present the product, the packing of the product, accounting, the actual cash process, cash in the money, advising the client, and selling the product as such. And then we have to check out which of these is routinizable, and we find out that 4 of these 6 are routinizable. Okay? I don't want to discuss that in very much detail. We can come to different conclusions about this. But the basic idea is we can look at all jobs and we can look at all tasks within these jobs and just ask ourselves, can we routinize some of these tasks? And if we say so, that 4 of these 6 are routinizable, that means the full job as a salesperson can be routinized by 2/3. Okay, 4/6. And coming from this discussion, we can then define the job content as a manual routine content of a job, a manual non-routine content of a job, cognitive routine, and cognitive non-routine. And the basic idea is that the manual routine and the cognitive routine jobs, they are basically, I'm exaggerating, disappearing. Okay? The number of these jobs is going down all over the world. So what are we doing now? We are using now data from Austria to look at such routinized jobs. We have the universe of Austrian unemployment spells in the early 2000s. We want to expand it a bit later, and we use a random draw from these unemployed because it's just too much to handle in a serious statistical program. So we use a random draw of 70,000 individuals. We look at unemployment duration of these unemployed persons, and we have information for these unemployed persons from the Austrian Employment Office. All these data are anonymized, so we don't know names and social security number of these persons. We only know the social statistics of these persons. And then we calculate the routine task index for all occupations these workers had in the past, following Otto and Thorne. And then, and I'm not going to talk about that too much, but there's also something similar which is called offshoreability, which means whether a job is highly likely to be offshored to some other shore, let's say to China or Hong Kong, whatever. Okay? And then we use also this index about offshoreability. And we can link these indices about routinization of jobs and offshoreability to this sample of unemployed persons in Austria. Then we define basically 3 task groups: the routine, cognitive, what is it? We basically take the routine, cognitive or manual workers, non-routine manual, and abstract workers. And then we calculate for each occupation such an index which is basically measuring the component of routinizable tasks within a job or an occupation. And we do this for some 200 occupations, and the index basically is based on 25 tasks. That's not the complete description of these jobs. It's, I would say, a kind of artificial description of these jobs. This is how people have done that in very large surveys. They have asked people in kind of time studies, what do you do for your day? Which tasks do you perform during the day? And they asked a couple of thousand workers about their jobs, and this is the information we are using here. To give you just some examples about the non-routine cognitive task, there's analyzing, planning, programming, buying, advertising. Non-routine manual would be gardening, repairing, building, installing, restoring, cleaning, and so on. Routine cognitive, paperwork, calculating, bookkeeping, accounting. Routine manual jobs would be to equip machines, handling machines, and producing something. So what is the statistical econometric problem we are facing here? Well, we basically have here the time axis, we have here an unemployment spell, and we basically want to understand the probability to leave the states of unemployment during this period, okay? And I have to basically calculate this probability at each point of the unemployment spell. And of course, I will need some functional form to do this calculation. And then there's another unemployment spell, and this person has a retraining. Okay, for instance, he's going to the employment office, and they tell them you should go to a retraining instead of, I don't know, a carpenter. You will be retrained as an economist, for instance. And there is this, again, for this person, the probability to leave the unemployment spell, and the person basically can leave any time during and after the retraining spell, of course. The problem is we don't really know, well, we do know, but the problem is when does the person receive this training spell? At each time here, there is a probability that the person can receive a training spell. We have to take that into account. Why is this a problem? Well, the problem is the following. We want to understand whether the outflow rate of the unemployed changes due and in the periods of the retraining. Okay, so for instance, I want to understand if there is a process of leaving the unemployment spell, is this process different in a period when there is retraining? Okay? And of course, the obvious idea would be because this person is retrained, there's a higher probability to find a new job, right? That's the easiest idea. This is what we want to test. But unfortunately, there's this problem that we might get training exactly because we have a bad chance to leave the unemployment spell. So for instance, if there are two persons, one person has excellent chances to get a new job, another person has no chance to get a new job, then it's highly likely that the person with low chances will get the training more often than the other person. And if this is so, then we have to model these processes jointly in a statistical sense. So what we do, we model the selection into training and the selection and the probability to get out of unemployment using the so-called timing of events approach. And this approach has been introduced by Abring and van den Berg in the early 2000s. And the basic idea is there's one important identification assumption we need in order to use this approach. And this assumption is the so-called no anticipation condition. And that means the exact beginning of training cannot be anticipated by a job searcher. Okay? So in clear words, it means, well, if I am an unemployed person, I know that I might get some training at the employment office, but I don't know exactly when this training is going to start. Why do I need this condition? Well, we need this condition because basically we want to differentiate the chances to getting out of unemployment in the periods before getting a training and afterwards, and there should be no anticipation effect of the unemployed. So in other words, the probability to get out of unemployment of this person before the training should be not different from the probability of this person here. If there would be an anticipation, then the person would already, I don't know, if they don't like the training, they would try to get the job even faster than somebody else. Okay, this should not be the case. That's the major condition. Okay, well, basically we model these transition rates in a multi-proportional hazard form, and I don't think I'm going into too much detail. It's probably sufficient to talk about the exit rate from unemployment, and here we have basically this probability to get out of unemployment depends on the time t you are already unemployed, and this can have any form, and this is multiplied by additional effects of some covariates, like the age, education, training of the workers, whatever. And there's an effect of being in a job which is highly routinizable. This is what I call RTI. And there's an effect of being into training. Okay? And this is basically what we want to understand. Okay, give you some empirical descriptive details of how do our data look like. Well, basically we have here exit hazards of men and women, which means it's not exactly that, but it means more or less the probability within a certain day to leave the unemployment register. So what we see that at the beginning the probability is going up. In the first 2 months or so, the probability is highest. And then the probability to find a job is going down. So, I mean, if you are already unemployed for 400 and something days, the probability to get a job the next day is practically nil. Okay? But that's not what I want to show you. What I want to show you here is the bottom third of RTI and the top third of RTI. We see that persons having a job which is highly routinizable have much lower probabilities to leave unemployment, at least at the very beginning of the spell. I mean, later on, the whole thing is collapsing. There's not much chance anyway. Okay, so give you a part of the results we have. What we see here is for men and women, we see here the probability to get a training. This is the first. Then there is the probability to get to leave unemployed to find a new job. And there's also a probability to leave unemployment to do basically nothing, not to have a new job, but these persons could go into, maternity leave, or could go into retirement or into some sickness spell or something like this, but not in a job. Okay? What I'm particularly interested in is these probabilities to find a new job. And what we see is basically in the red figures, what we see here is that persons who have a job which is highly routinizable have here a lower coefficient, which means the hazard rate out of unemployment is lower, which means the duration of the spell is getting longer. Okay? So those persons with highly routinizable jobs have longer unemployment spells, and this is also the case for women. It's even larger the effect for women, if you see. Okay? Well, then the second question I wanted to answer is, what can we do with these persons? Can we retrain them somewhat? And unfortunately, I don't know what retraining these persons get. I only know whether or not they get retraining from the employment office. So what we see is that the retraining basically has a positive coefficient on the hazard rate, which means the duration of unemployment is getting shorter. Okay? So these are the first coefficients, and then we do some simple interactions to see whether there is an interaction effect which means perfect, which means persons who have a highly routinizable job, they even profit more from the retraining than other persons. Okay, so basically the findings are the routine job content increases unemployment duration. It reduces significantly the probability of being employed in better or equal paying jobs. This I have not shown you here, okay? Routine jobs is positively correlated with receiving retraining, and this retraining has a positive effect on the probability to find a new job later on. So what else to come? There's a couple of other things we want to investigate in the future, except just improving this paper even further. What we want to do, we construct a matching between job vacancies and the unemployed, and we will look at these job advertisements over time, and we want to understand how the technological progress is adding on in these job advertisements. Can we see effects of digitalizations in the way how firms frame these job advertisements? And we have something like 70,000 such advertisements for a year. And we use data for all vacancies in the last 15 years, and we analyze these job descriptions to understand how these jobs change over time, and potentially what the effect of these changes over time will be on the chances of the workers in the near future. Thank you very much.